A hotel offers free breakfast to its guests. One morning, the hotel has 3 different kinds of juice, 4 different kinds of cereal, 2 different types of pastries available. If a guest can choose 1 kind of juice, 1 kind of cereal, 1 type of pastry, how many possible? So I told you we can use the fundamental counting principle if there's 1 of each. We agree? That was what I said. They have to be 1 of each. So this one we can. We can go 3 times 4 times 2, which is 24. Now I'm going to change this up because on the test it may not ask it this way. It may say, and we're going to pay attention because this is how I can twist it. Remember I told you I'm going to go over it if it's not 1 type of each. So if it said one morning they have 3 kinds of juice, 4 types of cereal, and 2 pastries, and they can choose 2 juice, 1 pastry, and 1 cereal. We can't do blanks then because they're choosing 2, right? So we have to decide. Are we going to use a P or a C? Does the 2 type of juice order matter? No. In which I pick? No, it doesn't. So we would just use C's. So if I did 2 type of juice instead, I would go, that's 3, not 4. I would go 3 juice, choose 2, times 4 cereal, choose 1, times 2 pastries, choose 1. So instead of doing the blanks, could I have just went 3C1 times 4C1 times 2C1? Yeah, it would be the same thing. Because 3C1 is 3, 4C1 is 4, 2C1 is 2. It would get you the same answer. So on these, where you're choosing 1 of each, you could actually use the C formula and just choose 1 instead of doing fundamental counting principle. Okay? Yeah? Yeah. Okay. Number 1, determine the number of arrangements in tattoo. So this is the whole word. Is there anything being held anywhere, together, anything? Nope. So when it's just the whole word, we can just go 6 factorial, however many letters there are, over 3 factorial, 2 factorial. But we have to remember to put them in brackets, right? Brackets is key. So what's the answer to that? 60? Okay. This one. A new license plate in Alberta consists of 3 letters followed by 4 numbers. Letters are chosen from 24 acceptable letters, and they may be repeated. Maureen wants the first letter of her license plate to be M, which is an acceptable letter, and she also wants the 4 numbers to be the 4 digits of her cell phone number. This is what throws people off. And then these can be any letters, right? Any of the acceptable letters. Yeah. Now these are the 4 last digits of her cell phone number. Do they change? No. No. So mine is 4260. So it'd be 1111. Okay? Hers could be whatever it is. Huh? Pardon? That's probably better in here. And M is 1, and then 24. What's 24 times 24?
576.
576.
Big number, what that is.
Big spender. Okay, here we have a 7-player volleyball team must stand in a straight line for a picture. Determine the number of arrangements that can be made from this picture. How many of them are there?
7.
So we do?
7 spaces.
7 factorial or 7 spaces, or we could do what?
Yeah.
With the P. 7 P7. Boom. Or 7P6 would end up being the same thing. Yeah.
MVP. Because there's order doesn't matter.
Because the order does matter.
Why does the order matter?
Because you're lining people up in a picture. And it has the word arrangement.
So why does it matter who goes away?
Because you're telling you, because they're telling you. They're telling you to line them up in a picture. So if you line them up in a picture and then you move them, it's a totally different picture.
Yeah. So
AKA order matters. No, it
Well,
doesn't.
it does because you have to leave a person behind whenever you position them. You can't have the same person in 7 different spots.
Order matters when it's a picture.
Okay.
Because you're putting people in a spot, and if you move them, and it looks different. If I just was picking 7 people for a group, and they were in the group or not, and I wasn't arranging them in a picture, I wasn't putting them on a shelf, I wasn't doing anything like that, then it's a combination.
But the question doesn't say the order of where they stand.
The number of different arrangements. You're arranging them. So you're just putting 7 here, and 6
So the word arrangement
is a huge, like, I'm a permutation. Yeah. Okay. 3. Determine the number of arrangements for the picture if the 2 tallest players must be together. Okay? 1, 2, 3, 4, 5, 6, 7. We're going to hook them together. I have 2, then I have 1, then I have 5, 4, 3, 2, 1. Then I'm going to multiply by
6 because they don't have to be.
yes, 6 because they don't have to be in the front. So it's 6 factorial times 2 factorial, or 6 factorial times 2, because 2 factorial is 2 times 1, which is 2, which is 1440. Thanks. Okay, determine the number of 3-digit odd numbers that can be created using the digits 0 to 9 without repetition. 1, 2, 3. 3 to 9 without repetition. So I have 1, 3, 5, 7, or 9. So I have 5 options. I hold the 9. Then I have 0 to 9 here?
No.
0 to 8?
No.
1 to 8?
Yes.
Why?
Can't
Can't start with an ear. Done, goofed. Put an 8. Hold the 8. Now I used up 8 and 9, so I have 1 to 7.
Add 0.
And I have to remember a 0. 8. 8 times 8 times 5 is?
12. Oh, that's what I said.
You are
said
wrong.
it was a different answer.
All right.
320 was my first answer. That's what I told you. You said it was wrong.
So we have library books at Grand Prairie Regional College. All have barcodes. Barcodes have 14 digits, and the first 8 digits must be 3, 1, 8, 4, 7, 0, 0, 0. So the first 8 digits, one option, one option, one option, one option, one, right? The remaining 6 must be filled with anything else. The number of different barcodes. Does it say they can't repeat or anything? No, so it's going to be 10, 10, 10, 10, 10, 10. Could I show the first 8 blanks with 1, 1, 1, 1, 1, 1, 1, 1, 1?
I do.
So that's 10 to the 6.
Can it be 0 to 10?
That's a 5.
Wait, that wasn't.
Like,
That was
wouldn't it be 11?
that was a
It's gonna be
6.
0 to
You can't have a 10.
That's what I thought too. I thought it was a 5.
I thought it was with
No, I mean, like, couldn't you go, like, oh, wait, actually,
No.
All
Alright.
All right. Tim and Rebecca are first and second students in line. Tim, Rebecca, first, second. In a line. 7 students waiting to buy tickets for a concert. They're in a line. If they're in a line, order matters. And if you say order doesn't matter, well, let's think about buying an Xbox. And there's 7 people in line, and the first 6 get an Xbox. Does the order matter? Yeah. So when you line people up, order matters.
How do you know Tim's in front of Rebecca?
Tim and Rebecca are first and second students. They're not the first 2. No, I'm not. 7 students waiting to buy tickets for a concert. Shh. The number of different order students can line up behind. There's 5. So we have 5. Then you go 4, then 3, then 2, then 1, which we could represent as 5 factorial or 5p5. Because we start at 5 and we go down by 1 each time. So then we can use the p formula. So it is. The word positive. P-O-S-I-T-I-V-E. So, how many different arrangements are possible if all the vowels must be together? There are 4 vowels. There are 8 letters. Before I go and do any work, in the bottom I'm going to put 2 factorial so I don't forget the 2 i's. Because often you forget that if you don't do it in the very first step, right? Now, we have 4 vowels, so I'm going to hook them together. So I have 4 for here, 3, yep, 2 i's and O and an E. 2, 1. Then I have 4 letters left, 4, 3, 2, 1. Does it say together at the front? No, so we have to multiply by 5. Because there's 5 spaces. There's 1 here, 2, 3, 4, 5. So I get 4 factorial, 5 factorial, over 2 factorial, which is D. No, it's just right. Okay. Nicole misplaced a 7-digit phone number. She knows the number begins with a 4 And the last 6 digits are 1, 2, 3, 5, 7, and 8 in some order. The number of phone numbers that satisfy these conditions. So she has 6 numbers in any order. So this is 1. Then I could have any of the 6, correct? Then I have to hold 1 there. Then it's 5, hold 1, 4, 3, 2, 1. 720. 3-digit numbers less than 400. If the last digit is a 4 or a 5. So I have a 4 or a 5 back here. So that's 2. Did it say I can't repeat anything? No. It has to be less than 400. So I have 0, 1, 2, 3.
Oh, that's so much. It can't be 0.
It can't be 0.
Yes, it can.
Nope. It has to be a 3-digit number. You were right with how you did it. Okay. So we have 3 here. And then here we'd have 0 to 9, which is 10. So it's 60. I had you almost convinced that it should be that way.
You read it. Yeah, it is. Look at my work.
Okay. These ones, you have to treat them as like dir, remember? So this is D, 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 R, R. So that's one word we have to do. And we have to do the other word, which is DR. And we need to go through these paths and these paths to get to the school. So we go 5 factorial for the 5 letters, because it can be in any order. And then on the bottom we have 3 factorial, 2 factorial. And I have to multiply. And then rearranging DR, I could go 2 factorial. Could I go 1 factorial, 1 factorial? Yes. Do I have to do 1 factorial, 1 factorial? No, because that's just 1. So, it's going to be 120 divided by 60, which is 20 divided by 2 is 10. 10 times 2, is it 20? Yeah. Yeah. Okay, we have the word intersection. INTERSECTION. So no matter what the question is going to be, I'm going to have 2 factorial, 2 factorial. Do I need the factorial symbols when it's a 2? Can I just go 2 times 2 times 2 times 2? It's 2. What's 2 factorial? 2. So 2 factorial is 2 times 1, which is just 2. So the only one I can drop the factorial symbol off on is a 2. Because 3 factorial is 3 times 2 times 1, which is actually 6. So I could have wrote 2 times 2 times 2 times 2. Now it says the vowels cannot be together. So I have to do total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 factorial over that. That's the total, no restrictions, if I just did intersection. And then I have to subtract off the vowels together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many vowels are there? 1, 2, 3, 4, 5. So then I have 5, 4, 3, 2, 1. Times, how many left? 7, 6, 5, 4, 3, 2, 1 times 8. That was one more. Can someone do this? Can you get an answer? $302,400.
Oh wait, that was just the drawing.
So the second one? First one. Okay. So we'll go. Join me. Whatever. Total answer is what?
296,35200.
29,635,200. Now here is given a committee of 14 principals and 30 teachers, which is 44 people. How many different 6-person committees will there be? If that was the question, if that was all it was, you would go 44C6, right? But that's not the question. It says exactly 4 teachers. So I need a 6-person committee, subcommittee. Does it have jobs for those 6 people? No, so I'm going to use C, because order doesn't matter. It's a combination. So I'm going to go 4 teachers, but what do I have to remember to add? And 2 principals. Because I need a 6-person committee. Every single time, that's the key thing you have to look for. How many people you need on the committee first off, and then go to the question because you might have to supplement to make sure you have 6. So here we're going to go 30C4 and 14C2. Why am I multiplying? Because I need 4 and 2 to make the 6, not 4 or 2. So what do we get for an answer? 249 what?
855.
Oh, there's a 3 in there.
I was like, that is not what Hunter said. 2,493,000?
Yeah.
855. I was like, you had one more digit in your answer. At most 3 principals is one of those standard of excellence questions, and at most means most or at least means I'm going to get cases. If I need at most 3 principals, that means I need at most $3, which means I would need $3 or less. So we need 3 principals or less. So I'm going to need a case with 3 principals, or a case with 2 principals, or a case with 1 principal, or I can't forget the other case that everyone forgets, no principals. Now, each of these cases needs to have a subcommittee of 6 people, correct? This one is 3. So I need 3 principals and 3 teachers, or 2 principals and 4 teachers, or 1 principal and 5 teachers, or 0 principals and 6 teachers. So I'm going to go 14C3 times 30C3 plus 14C2 times 30C4 plus 14C1 times 30C5 plus 14C0. Do I need to state that? No. So I can just go 30C6. If I did 14C0, would it be wrong? No. Just more work typing your calculator. What do you get for an answer?
6,560,554.
Perfect. Awesome. Okay, I'm going to get you to open up your notes to the set theory where we left off. So we went over subsets. In order for something to be a subset of the other, everything from that set had to be contained in the other one. So an example, O, which was 1, 3, and 5, was a subset of L because L contained 1, 3, and 5. L could contain more, that's absolutely fine. But at minimum, in order for O to be a subset of L, L had to have O in it. Okay? So O is also a subset of O, L is a subset of L, because they contain themselves, right? So what?
L wouldn't be a subset of O though?
L would not be a subset of O because all of L is not known. Yeah. So immediately if a set is bigger than the other one, it can't be a subset of it. Good call. Okay, empty set. The empty set is a set that contains no elements. Now on your formula sheet, which I'm getting this weekend, I'm doing this to yours as well. I have to get a person to help me. I'm making a hard copy so that you can just have these for your test and not write on them, but then I don't have to give you a new one each time. I haven't made them, I just have to list them first. So on your formula sheet, this is the logical reasoning spot. It's on the far bottom right. There is empty set here. It has a 0 with a line to it. So if you forget what that symbol is, you can go look. It tells you what it is. So the notation for the empty set is a 0 with a slash. For example, the set of odd numbers in set E is empty, because there are no odd numbers in set E. And the empty set comes up more when we deal with putting what's in this set and in this set, or what's in this set or this set. So for example, if I said, what is in O and in E? What numbers are in O and in E? None. So then you do the squiggle brackets with empty set. Because there's nothing that's in O and in E. So that's where empty set's going to come up more, not right now. Complement of a set, that's also on there, it's the top one, A with a little slash. So it's the complement of a set is the set of all elements in the universal set that are not in set A. So the complement of set A is denoted as A with a little slash. The complement of set E, we're going to use proper notation. So we're going to go E complement equals, and we do the squiggle brackets. Now if you want to draw the squiggle brackets correct, on the left it's forward S, backwards S, if that helps you. You could go forwards S, I go forwards S, backwards S, and then the other one's backwards S, forwards S. So we want to say what's in the set, what's not in E, but's in the universal set. That's what E complement means. So what's not in E, but's in the universal set. So our universal set was the numbers 0 to 9. We agree?
Yes.
And in E we have 0, 2, 4, 6, or 8.
They're all in there.
So what's not in E?
Oh.
1, 3, 5, 7, 9. Okay? You do what's not in L. You try that. So L has 0, 1, 2, 3, 4, 5, 6. L does not have what? 7, 8, 9. So the complement of L is 7, 8, 9. So we're going to look at example 2. Consider the following two natural sets. The natural numbers less than 20 that are divisible by 3. The natural numbers less than 20 that are divisible by 5. Okay? Explain why the set of natural numbers less than 20 is a suitable universal set. Why is the natural numbers less than 20 a suitable universal set for both of these sets?
Because the universal set only goes 0 to 9, right?
That was the previous one.
Oh, God.
The universal set can change. It'll change for each question,
Okay,
right?
let me write that down.
And so this one says the natural numbers less than 20 divisible by 3, natural numbers less than 20 divisible by 5. Both of them have the natural numbers less than 20, correct? That is our big encompassing universal set. So why is the set of the natural numbers less than 20 suitable? Because it's what they narrowed down both of these to be. It's what it is, the narrowed down set. Because for both of these, I'm only allowed to look at the natural numbers less than 20, right? So I'm not allowed to look at anything outside of that for both of them. So that's an appropriate universal set because that's what it narrowed it down to be. So the universal set in this case, natural numbers start at what? 0. No. When you're naturally a baby, what do you start counting at? 1. I don't know babies that count at 1, but maybe they 1, 2, 3, toddler. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Do I include 20?
Less than some.
Less than, so no.
Can we just go 1 to 19? Like just go 1 dash 19?
No, because that would include decimals, right? So, I want you guys to do B, C, and D. Try them out. B, C, and D. And press the silence. Okay. No. Did not mean to do that. No. Yeah. Okay. So, we have 3, 6, 9, 12, 15, and 18. E are divisible by 5, so we get 5, 10, 15. Complement of A is everything in there but not in A. So 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19. So we listed everything that's in the universal set but not in A. Write a description of the complement of set B in words. So what would be your description? Complement of B. We'd still have to have natural numbers less than 20. That are not, yeah, so that are not divisible by 5. So we can just do this, but not. C are the natural numbers less than 20 that are multiples of 6. So C is going to be 6, 12, 18. Those are the multiples of 6. I have to stop there because it's still natural numbers less than 20. Now I have to look. Is C a subset? That's what that means. A subset of A. Is everything in C in A? So A has 3, 6, 9, 12, 15, 18. C has 6, 12, and 18. Is 6, 12, and 18 all in A? Yes. So yes, true. C is not a subset of B. Is 6, 12, and 18 in 5, 10, and 15? No. And to be not a subset, just one number doesn't have to be in it. So for example, bless you, if 6 and 12 were in B, but 18 wasn't, it still wouldn't be a subset. So every single one has to be in it. So this is true. Not A is a subset of not C. Well, not A has 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 18. Not C, we should write out what it is. Not C is everything but 6, 12, and 18. So it's 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 19. So is everything in not A and not C? Well, let's check. 1, yep. 2, yep. 4, yes. 5, yes. 7, 8, yep. 10, 11, 13, 14, 16, 17, and 19.
Yeah.
So it's true as well. Is not C a subset of not A? No, because not C has more stuff than A, right? I'm going to hand out this, and you're going to do these questions.